Greetings, ladies and gents, and welcome back at Mike Maths and Science Club. In this video, we'll be looking at a question which was written in September 2018. It's a question on vertical projectile motion. So they said that ball Y is thrown vertically upwards from the ground at a velocity of 20 meters per second, as they shown there. So that would be a ball Y. So in this case, it was thrown at a velocity of 20 meters per second, vertically upwards. So in this case, that's the first thing we need to note. There would be the direction of that of the velocity of that object, which is Y. So this is that at the same instant, at the same time, a second ball X is dropped from a balcony 50 meters above the ground. Refer to the diagram below. Ignore the effects of air resistance. So that statement again that it says ignore the effects of air resistance, it simply means that of course we are in free fall, meaning that the only force that will be acting on those objects would be the gravitational force only. There will be no other force acting on them besides the force of gravity. In this case, so for 3.1, they say that define the term projectile. So in this case, the term projectile simply means that it simply means that an object, in this case, have been given an initial velocity and moves under the influence of gravitational force only. So that's so the formal definition for projectile. I don't know why, sometimes you just write the term projectile and then sometimes projectile motion. So in this case, for the word projectile and projectile motion, those are simply the same thing. So projectile motion would be, in this case, any object that has been given an initial velocity, it moves under the influence of gravitational force only. So that's the formal definition for projectile or projectile motion. So for 3.2, now do not be alarmed by what I just say. Hey, the projectile motion, projectile, those are the same things. So in this case, but do not confuse free fall and projectile motion. Those are completely different things. So in this case, for 3.2, they said that calculate the time it will take the balls to pass each other. Now, one thing that you must really be careful, and of course something that will not change, when it comes to this questions, is that now if you look at ball X, so ball X in this case was dropped right from a certain height. So in this case, now one thing that now remember that of course while ball Y was traveling upwards, let's say, of course going upwards. Let me just take that pen. So while it was actually traveling upwards, all right. So in this case, we know that of course ball Y was also traveling downwards. So in this case, this would be ball Y traveling upwards. So in this case, we know that of course, in this case, at the same instance, we say that while ball Y was projected, so in this case, ball X was also dropped, right? So in this case, of course, ball X was also traveling downwards. All right. Now, one thing that you must note: so when these two objects pass each other, right? So when they pass each other at that point, right? So in this case, we know that of course this would be ball X, right? So ball X would be, of course, at that position there. So one thing that you must note is that when those two objects pass each other, they would have one thing that would be in common. So in this case, the one thing that these two objects will have in common at that point would be the height above the ground. So in this case, the height above the ground when these two objects pass each other would actually be the same. And of course, also the height above, below the building. Of course, if they are thrown, if one, of course, is thrown or dropped from a certain height. So in this case, we know that of course the distance, below the building, and of course where they pass each other would actually be the same. So in this case, I know that of course the height, now when they pass each other above the ground, it would actually be the same, right? So in this case, what I'm gonna do, I'm just gonna call this height above the ground, right? I'm just gonna call it X in this case. So in this case, that height above the ground, right, would simply be X. Now if this is X, so that would actually mean that that height there that would actually be left would be X, would be 50 minus X. Right, so in this case we know, so this would be that remaining height. So in this case, if we have traveled X meters above the ground, if we are X meter above the ground, so that would mean that in this case what would be left in this case would just be 50 minus X. So in this case, I know that would simply be 50 minus x, right? Now in this case, so what we know, so they said that calculate the time it will take, the balls to pass each other. So the first thing that you must notice that the one thing that those objects have at that point would be the height above the ground, right? Or the display, yeah, let me just rather say the height above the ground. So in this case it would actually be the same. So that's one thing that you must note. Now one thing, so what I'm gonna do in this case would be, of course, to gather my data, of course, that I have, of course, on pole X, so between, of course, that point, between the starting point and, of course, the finishing point, of course, the final point, which would be, of course, when they pass each other. So what I'm going to do, I'm just going to try to label, these points. So in this case, what I'm going to do would be, I'm just going to label where, pole Y started as point A, where they passed each other is point B, and of course the starting point of pole X is point C. So that's simply what I'm going to do. So in this case, I know that, of course, the distance between A and B, right, would be X, right? And then, of course, the distance between point C and B would simply be 50 minus X. So what I'm going to do, I'm just going to gather my data that I have between point A and B. So in this case, with these type of questions, we, normally have to do, a simultaneous equation. So if in this case, now remember that we don't know how high was pole Y when these two objects passed each other, and we also don't know that after how many seconds did these objects pass each other. So in this case, that's what they are asking us to calculate, right? They said that calculate the time it will take the balls to pass each other. So in this case, what I'm going to do would be, now what I'm going to do, I'm just going to get the data for ball Y first. So in this case, now before you even do anything, you must choose which direction you're going to take, as a positive direction. So in this case, what I'm going to do, I'm just going to consider going up as positive, as down, and downwards is negative. So in this case, I know that, of course, since that pole Y was thrown upwards, so in this case, I'm just going to take the data between point A and B for ball Y. So in this case, for ball Y between point A and B. So this would be for ball Y. So in this case, I know that between point A and B, now what do I have between those 2 points? I know that, of course, the V initial was given as 20. Now it was traveling upwards, so in this case this would be positive 20. All right, so in this case I know, so let me just write it on that other side, in this case, so that I will have enough space to write. So in this case, I know that, of course, between point A, so this would be for ball Y. So this is between point A and B, right? Because I want to know, the time taken for that object to pass each other. So I want to know that the time, traveled by ball B from point A to B, right? So in this case, I know that, of course, ball X would actually take that same amount of time to travel between a point, that point C and B. Why? Because we know that, of course, the object were thrown at the same instance, in this case, or at the same time. So in this case, between point A and B, I know that V initial would be equals to plus 20, right? Because we took upwards as positive. And I know that, of course, V final, I don't know that at what speed or at what velocity was that ball Y traveling when they passed each other. So in this case, the velocity will not be the same when those two objects pass each other. So in this case, I know that, of course, delta Y in this case will simply be equals to x, right? Because in this case it was displaced x meter above the ground, so we considered going upwards motion as positive, right? So in this case, I know that delta t would simply be, I'm just gonna represent that as t rather. So in this case, that would be t. Let me just scroll down again. So in this case, what I have now, in this case, now the other thing that we would need to take note of would be the gravitational acceleration value. So in this case, we know that, of course, this object accelerating, but in this case, they're always accelerating at 9.8 meters per second squared. But in this case, the direction of that acceleration will always be vertically downwards, right? So in this case, we know that, of course, delta A would simply be, now we took upwards at positive, and we know that, of course, the gravity is always pulling our objects vertically downwards. So as a result, that A would simply be negative 9.8. So that would be due to the fact that I took upwards as positive, and I know that, of course, that value of A would be vertically downwards. So in this case, we say that downward would be a negative. So in this case, I know that between. So in this case, one. Now remember that I'm looking for time. All right. So in this case, I'm looking for time, but I don't know. In this case, I'm looking for time actually, which is what I have down here. So in this case, I'm looking for time, right? But in this case, I don't know the final velocity, right? So in this case, any equation that I'm going to choose mustn't have the final velocity. So in this case, so in this case, I know the initial velocity. So the equation that I'm going to choose would just be the equation that says vf, that says vi. That simply says delta x actually. So it says delta x is equals to vi plus in this case a half, that's multiplied by delta t actually. So that's multiplied by delta t plus a half a delta t squared. So in this case, I know that of course my displacement, we say that's x, right? So I'm just going to put that as x, and then I know that v initial, that was 20, that was 20, right? And then of course time, we represented that is t, so this would be t multiplied by t plus, in this case, a half. That acceleration, we say that's negative 9.8. This case delta t, that would be t squared. Alright, so this would be the equation that I get, of course, when I gather the data between point A and B, in this case in relate to object Y. So I'm just gonna leave that as it is. I'm just gonna look at the information that I have in regarding, of course, to that ball X. So in this case for ball X, so in this case this would be for ball X. So I know that of course for ball X between point B and C, or between point C and B. So in this case, what I have would be, so in this case between point B, between C and B. So I know that of course VI is a 0, because they said that the ball was dropped, right? So in this case, I know that VF, so that's unknown, right? But I know that of course the displacement, we say that would be 50 minus x, but we know that of course that object in this case would be displaced downwards, right, from where it was thrown. So in this case, the displacement would simply be negative 50 minus x. So that would be the displacement. That negative there would not the fact that it was displaced and 50 minus x downwards, right? So in this case, we would have negative there. So in this case, delta t, we say that of course it took the same time, right? So in this case, this would be a t. All right, and then of course the acceleration would simply be negative 9.8. So we know that of course a would be negative 9.8. So in this case, I'm just gonna choose that. Now remember that of course I don't have the final velocity, right? But in this case, I have the initial velocity, and of course I also have the displacement being 50 minus x. So in this case, I'm just gonna choose also that equation that says delta x. So in this case, this would be delta x is equals to a vi delta t plus a half a delta t squared. So in this case, what I have would be delta x being a minus, in this case minus, that would be 50. Alright, so this would be 50 minus x. Right, so this would actually be equals to vi, which is 0. Right, and we know that of course the initial velocity of that ball x would be 0, multiplied by t, right, which was time, plus a half, in this case delta, so this would be negative 9.8 multiplied by t squared. So in this case, this would be the equation that I get. Now what I'm gonna do in this case would just be to make x the subject of the formula. Why? Because in this case I'm looking for time. So in this case, if I distribute that negative, I would have negative 50, right, plus x being equals to a half negative 9.8 delta t squared. So in this case, if I isolate that x, I would simply have x, right? So I would have x being equals to a half of 9.8. So this would simply be negative 4.9. So in this case, I would actually have negative 4.9 t squared. in this case plus 50. Now remember, when I take this 50 to the other side, it becomes positive since it is negative. So but in this case, what I'm going to argue is that but x is equals to x. So in this case, what I'm going to do, I'm just going to equate those two equations. So what I have would be the first x being negative 4.9 delta t squared plus 50 being equals to, of course, the equation that we have there being equals to, so we say that would be 20 multiplied by delta t, so that would be t minus 4.9 t squared, so that would be t squared, right? So that's what we have there. So in this case, what you can note would be that I thought actually that we are going to use a quadratic formula, but what we can note that is that this would simply cancels with that. So this negative 4.9 squared will simply cancel with the negative 4.9 squared on the other side. So what I'm left with will simply be 50. So right, so this would be a 50 being equals to 20 t. So that's what we have there. So in this case, what I'm going to do, I'm just going to divide by 20 on both sides. So in this case, I would have t. If I do that, I would have t being equals to, so in this case, this would be 50 divided by 20. So if I put that into the calculator, so what we have would be, in this case, 50 divided by, so this would be 50 divided by 20. So in this case, that would give us a time of 2.5. So in this case, we would know that, of course, the time would be 2.5. So I know that, of course, t will simply be equals to 2.5 seconds. So in this case, those objects passed each other after 2 seconds. So in this case, for that other question, which would be 3.3, they said that calculate how high above the ground ball X will be at the instant the two balls just pass each other. So in this case, they want the value of X. So in this case, how high how high above the ground ball X would be, right, above the ground. So that would be at this point here that we have right there. So in this case, we know that, of course, the height above the ground that ball X would be, it will simply be that X. Now remember, we said that when those two objects pass each other, they would actually have the same height above the ground. So in this case, we know that that would actually be X. So in this case, what they are asking us to calculate there would be the value of X. So in this case, I know that, of course, since delta t would be 2.5, so I'm just going to use that equation that we have there, so that we have right here. Why? Because in this case, we already have X isolated. So you can also use that one. You're actually going to get the same answer nonetheless. So in this case, in answering that question, which is 3.3, so in this case, I would simply say that delta X, all right, let me just write that. So in this case, I know that for delta X, so I know that for 3.3, I know that delta X simply equals to a negative 4.9, in this case, t squared. So this would be t squared. So in this case, I know that, of course, what I would have there would be, in this case, a negative 4 multiplied by. Now, in this case, for ball, so in this case, this would actually be for ball X, right? So in this case, this would be in relation to ball X. So let me just scroll that up. So in this case, this equation that we got here was, in this case, for ball X, right? So in this case, I know that ball X was displaced 50. So in this case, that was actually, we had a plus 50. So in this case, this would also be plus 50. So I forgot to add that plus 50 there. So this would be plus 50. So in this case, we would know that, of course, we have negative 4.9. All right, so we have negative 4.9 multiplied by t, which we found as 2.5. We square that plus 50. All right, so in this case, what we would have there would simply be, let me just take the calculator out again. So in this case, we have a negative 4.9. We multiply that by 2.5. We square that plus 50. So So in this case, we know that of course delta x will simply be 19.375. So in this case, we know that of course delta x, so delta x, actually say delta t now. So in this case, delta x will simply be equals to 9.375. So this would be 9.375. So in this case, they just asked that how high. In this case, they didn't ask. In this case, they're asking for the height above the ground. So in this case, we know that of course height would simply be that's a scalar quantity, right? In this case, that wouldn't actually need the direction. So in this case, for 3.4. They say now what now someone might ask what happens in this case if I had calculated that for in 3.2, because what someone might have done was of course would be to isolate that t in this case, and of course calculate x first. So in this case, what we would have done would be in answering that 3.3 would just to say refer to the question above if you don't want to rewrite all of that, or else you could write the same thing again. So in this case, for 3.4, they said that draw the position time graph for ball x from the moment it is dropped until it passes a ball y. So in this case, what we would do in this case, we would of course draw our sketch first. So in this case, we know that we have something like that. All right, let me just scroll down that we have, so that we have more space rather. So we know that of course we would have that. All right, and then we also have time. All right, so we also have time. Now remember that of course displacement is a vector quantity, so it can also be negative, but in this case what I'm just gonna do would be to also put time. But now remember that time is a scalar, it can't be negative, right? So it doesn't have a negative region. So in this case, this would be the position. So this would be the position, right, in meters. So in this case, this would simply be time. So we know that force ball x was thrown of course from a 50 meter high balcony. So in this case, this would be where ball y would be, right? So in this case, would have a ball y being 50 meter initially above the t0. So this would be 50. So in this case, we know that of course ball y would of course travel, and this of course until it passes that ball that ball wise. In this case, it would be at that point, but we know that of course at that point what we know that of course it was actually 9 point. Was that 9 point? Let me just scroll that up again. So in this case, it was actually at 9 point 375 above of course the ground, right? So in this case, so this position that we have here, it would simply be in this case that 9.375. so this would be 9, so this would simply be 9.375 that we have there. So in this case, now the time when they passed each other, we say that was actually 3 point, let me just scroll up again. So we have 2.5. So in this case, time there would simply be equals to 2.5. So we would have time. All right. So in this case, for time, this would simply be equals to. So this would be 2.5. So this would be 2.5. So in this case, this would be time. Now remember that of course time is measured in seconds. So that would simply be the position versus time graph of that for ball y, when of course it passed ball x. So in this case, I'm not gonna, the reason why I didn't actually let it touch that point would be because now they say that draw the position time graph for ball x from the moment it is dropped until it passes ball y. So this is where of course where it passed a ball y at this position here. So in this case, that's why I left it right at there. So in this case, this would be of course for that question, which is 3.4. So in this case would be to show of course the height of that ball above of course the ground, which would be that point, and then which is 9.375 where they passed each other, and then of course that 50 would be the initial where of course it started. So in this case, it started of course 50 meter above our ground. So this will be, of course, for question 3. And of course, if this video helped you at some point, be sure to like the video. And of course, if you haven't subscribed, please be sure to subscribe and hit that notification bell so that when the next video comes up, you'll be the first to be notified. Now, if you have got any questions, you are more than welcome, ladies and gentlemen, to throw that in the comment section. And of course, if you've got any past paper that you would love me to cover, throw that in the comment section, and I'll make sure that I cover that question as soon as possible. But as the story always ends, ladies and gentlemen, this is Say Mike signing out. Sharp, sharp.